you let fx be equal to e to the power of 3x plus 1. Okay. Then after that, you find f prime x. Okay. So it will be e to the power of 3x plus 1. Then you time by the derivative, that is 3. You are am I doing the right question? Exercise 4B 3C. Oh, 3C is square root, sorry. Never mind. I do already, I just do. Okay. So after I will do, this is 3B. You see already. Okay. So this is 3e to the power 3x plus 1. So you still remember antiderivative? If you integrate 3e to the power 3x plus 1 dx, you will get e to the power 3x plus 1, correct? So now they just 1 without the 3. So the whole equation you divide by 3. So you have e to the power 3x plus 1 divided by 3. Then you put a plus c at the end. Are you okay? Okay, I will do 3b for you. Okay, 3c. Okay, you also do the same. Let fx be equal to x root x. Okay, for this x root x, what we can do is you can change it to x to the power of 3 over 2, isn't it? Okay, so your f prime x will be 3 over 2 x to the power of half. Would that be okay? So therefore, if I integrate 3 over 2 x to the power half dx, I will get back my fx. So I write down. So I can take the 3 over 2 here. So this is like multiply with this square root, half is square root of x. So if you bring this over, it will become 2 over 3. So it's to the power of 3 over 2, you change back to x root x, then you put a plus c. So you get the answer. You get me? Okay. So whatever is it, please ask early. Don't wait until you finish the whole thing. Then only you, when come to exam, only you start. Okay. What happened to my CMS? Okay. Okay, please, everyone. Go on. Everyone, please key in your attendance first. Okay, we are doing 4C. Fundamental theorem of calculus. Okay, what do you mean by fundamental theorem of calculus? So all these case, class, please remember, I'm going to use the area is above the x-axis. Okay, so this is my y equal to fx. So you have to be very careful. I'm going to use small letter and big letter, capital letter of f. Okay, so I'm trying to find this area. So first of all, when I say fundamental theorem of fx, to find the area of the shaded region, so my question is how? to use fundamental theorem of calculus to find the area of the shaded region. Or in another word, I will say area bounded by the curve y equal to fx, small letter, straight line, x equal to a, x equal to b, and x axis. Okay, so how are we going to start this? How are we going to start this? So every time when you start this, you must write down this statement. That is capital letter Fx is the antiderivative of y equal to f, small letter fx. Okay, this means, listen here. This means fx is equal to capital letter F prime x. Understand? So you make this statement first every time when you do this type of question. Okay? So therefore, when I integrate a to b, fx, small letter fx dx, I will get my, am I right? That is the basic principle, the antiderivative meaning, am I right, that we have learned in 4B. So when you say fundamental theorem of calculus, this is exactly like when we say using first principle. You get me? Using first principle. Okay, so now, and we have the limit from A to B, correct? So you put a square bracket, A to B. So therefore, this is equal to F, the top, minus the bottom. So this is called substitute x equal to b, take away, substitute x equal to a into the first capital letter fx function. You get me? So this is called fundamental theorem to find the area of the shaded region. Or in another word, later I will give you an example to find the function if given derivative function. So everyone, any question on this? So if you understand this, when you read through the investigation by yourself, you will be able to understand. Are you okay?
Could you explain that again?
Okay, which one you want me to explain?
Just the therefore integration B to
Okay.
A.
This, therefore, the integration here is based on our 4B. Still remember, just now when we write this, you see, Anna? You see here?
Yes, miss.
So that is the meaning. Is that okay? You see all this here. Therefore, I make a conclusion. Is that okay? That means the fundamental theorem of antiderivative, that is integration. We write down this statement, then we are using this concept that we have learned. If that is in 4b, that we say if f prime, okay, f prime x. Okay, so that means if I write it in another way, if fx is f prime x, you see, I use both f, but one I use capital letter. Then I integrate fx dx. Isn't it? I will give back my fx capital letter. Then I put a plus c. Okay, why over here I don't have to put a plus c? The reason is because you have a limit, you substitute. So look at this case. If I substitute f b plus c, I take away f a plus c. You see what happened? So the c cancel off. So the constant, you see or not? So that's why this is a fundamental theorem. So every time when the question say use fundamental theorem of calculus, find this. Okay, that is for antiderivative. So you must write this statement first. Are you okay? So shall we? Okay, so we go to the next one. So the step is a must to write down properly. If you didn't write down properly, then you won't get the mark. It's exactly like when we do differentiation for the first principle. Are you okay? And we tap on this concept that we learned in 4b. Okay, let's move to an example. Okay, I will let you look at the example in the textbook by yourself. I will give you another example. Okay, example 1. Okay, I will always say use the fundamental theorem of calculus. Okay, so I'm not going to write in full to find the area between, I said the question exactly like the textbook, okay, but I give you different function. Between the x-axis and y equal to 1 over x from x equal to 0 to x equal to 1. Oh, no, cannot. From x equal to 2 to 3. Okay, for example, I give like that. Or 2 to 5. Okay, 2 to 5. Make it bigger, better. Okay, so now when we talk about fundamental theorem, okay, so this is like that. So now I have this situation. So I I graph it for you to have a look at it. This is my y, this is my x. If you graph it, so this is your fx, by the way. Sorry. Is my graph correct? Anyone? So this is my y equal to 1 over x. This is my small letter fx, okay? From the fundamental theorem. Okay, so I want to find the area from 2 to 5. Okay. So first thing, if I want to find this area, I don't know integration yet. Am I right? So I have to integrate from 2 to 5 fx dx to get the area. So I write down this first. So I will have to integrate from 2 to 5, 1 over x dx. Okay, so now I have to use the knowledge that I have about differentiation. I have to ask myself, what function when I differentiate I will get 1 over x. Think of a function. So now your task is you have to think of a function that its derivative is 1 over x. So now that is your task. So your friend have told me, okay, in the chat, that if I differentiate ln x, I will get 1 over x. So this is in your mind. So now, underneath here, I will write a statement like this. I will write a statement like this. I will say fx equal to 1 over x has antiderivative. I won't say integral. Okay, I will say derivative of, I put a capital letter and I put ln x. Okay, if I don't want to write like that, you also can have a choice to say that fx equal to ln x has derivative of which is equal to 1 over x. But the one in blue will be better because we want to talk about integration. Do you get me? So who is going to come up with this? For this our question, you. How you get it? Go back to your idea of differentiation. So am I going to tell you? No. Okay. So now how you write the next step after you have finished this? So the next step you will say that, okay, so I will write down 2 to 5, 1 over x dx is equal to, if you want to write this, the tick statement first also can. So it's equal to, I put a bracket. Okay, if you don't want to put a bracket, it also can. You can straight away go and substitute in, okay? But I will prefer to do that. So this is equal to, I told the examiner what is my fx already. So it's ln 5 minus ln 2. So equal to ln 5 over 2. So these are the steps for fundamental theorem of calculus for antiderivative. Do you get me? The one I write in red come from who? Come from the doer itself. The one who do this question, you have to come out. No one is going to tell you. And how I get this information? I get it from my understanding of differentiation. Have I made myself very clear? How to do this style of question? Okay, good. Any further question? So you should be able to do exercise 4C now by yourself. Question 1, question 2, 3, 4. Okay, I'm going to do, okay, question 5. 4C, can I move? Do you want me to give you some time to try to look at the example 4? So let's look at exercise 4C, question 5. So they say, use the fundamental theorem of calculus to show that, okay. So every time when you say use the fundamental theorem of calculus, you will always start with this statement. You will say that, okay, like for A, I will start with this statement, y equal to fx. That is what is in the integral, correct? Has antiderivative of fx. I don't know what is it for this case. Okay, so therefore, when you integrate a to a fx dx, you will get fa minus fa. So you get 0. That's it. Are you okay? So you prove the result algebraically. You get what I mean? So this is a very important statement. Okay, for part B, how am I going to? K is a constant, correct? So I will say y equal to k. Yeah, algebraically. So this is called algebraically. When you write this statement. Hello? So you see how important your first statement is. Graphically. Oh, graphically. Okay, graphically what you need to do is, sorry. Okay, so I will draw the graph. Sorry. Graphically, not algebraically. Thank you, Hao Xuan. Okay, so graphically, so what you do, you draw the graph. You don't know how is the function, correct? So you just draw, up to you how you want to draw the graph. Okay, y equal to fx. So you just draw a straight line like that. From A to A. So this is called graphically. This is called using fundamental theorem. Got it? Okay, for part B. Okay, where k is a constant. explain the result graphically. So how am I going to explain the result graphically? This is the area bounded by the curve y equal to fx, straight line x equal to a, and x axis. So it is a straight line. So it is a straight line, and its area is 0. So that is how you write. So you see, when you look at simple questions, right, the way you explain is very important. Okay, if for part B, how am I going to solve part B? So how you write? If I put graphically, then how are you going to write also? So I'm going to show you both. So for part B, what I do is, how I write? Y equal to K has antiderivative of okay, I'm going to call someone. Azif.
Yes.
What is the antiderivative for y equal to K?
Kx.
Yeah, of Kx, correct? Fx equal to Kx. Yeah. So I will write down like that. It's better to write down like that. Fx equal to Kx. Okay. So then only I write down integrate from A to B. So this will be KB minus KA. Right, so this will be KB minus A. So how are we going to show graphically if I want? I will draw a graph. This is not part of this question. So this is y equal to K. This is my A. This is my B. So you will say okay, integrate A to B, K dx is the area of the rectangles with the width of B minus A and height of K. So therefore, is K times B minus A. Done. You see? That is how you go. Okay? Student, are you okay? Should I do C, D, E? Should I let you try C, D, E by yourself? Or you want me to show one of them, C, D, E? Which one you want me to show? E. Okay, you want me to show E, huh? Okay. If I want to show E, okay, part E, so because I have the two function there, okay, I will say antiderivative of fx is fx, and antiderivative of gx is capital letter G x. So I'll do like that. So therefore, integrate A to B fx dx plus integrate, or I will do like that first. Hold on. Instead of split, I will split later. So integrate A to B fx plus gx dx will be equal to fx plus gx A to B. So this will be fb plus gb, take away fa plus ga. Capital letter, so this will be, I can rearrange it. Can I? So this will be integrate A to B fx dx. This is represented by this, am I right? Plus integrate A to B gx dx. Done. Okay, so it's just a manipulation of it and go on with it. Okay, so are you okay with the fundamental theorem? So very important statement. You state this statement, then you just play around with it. Okay, any further questions? So the moment they say fundamental theorem, you must take this statement. If you didn't state this statement, you won't get marked. Any further question? Do your work. Okay, so we are going to talk about 4C, means rule for integration. Okay, So when we talk about rules for integration, like 4D question 1, 2, 3, 4, you cannot use the rule. Can you have a look at 4D? Okay. Okay, 4D, sorry, 4D is not the rule. 4D is 4E. 4E, 4E is the rule. Do you have a issue on doing 4D? Okay, let me do one question in 4D for you first that we have learned in 4B. Actually, 4D, we have learned in 4B. Like for example, I do question 4 for you. They say, if y equal to this, find dy dx. Hence, you see, I got give you the question, correct? So, we will do it in this way. So you have to find dy dx first. So this will be 8. Correct? Then you will say, therefore, if I integrate 8 times of 2x plus 1 cube with respect to dx, I will get my 2x plus 1 to the power of 4. You integrate this, you get back there. So, but the question don't want the 8 there. Am I right? So therefore, if I integrate the whole thing, I divide by 4, by 8. So you have to do 4D, you have to do this process. You cannot use your formula, understand? Then you put a plus C there. It's a must to put plus C. So you get full mark. So 4D, all the question you have to do it this way because they use the word hence. Are you clear? So please practice your 4D. 4D is related to 4B. Yep. Can I? So I'm going into the rule for 4E. 4E.1, 4E.2. Okay, so I will stop at 4E first. 4F is also the rule. Yeah, so I'm going to 4E. Okay, 4E is only one rule. Okay, so when you talk about rules, every one of us have to remember, first thing, integrate 0 dx, what do you get? Bram? Integrate 0 dx, you get 0. You have to think now. You differentiate constant, you get 0. So you integrate 0 the other way around. If I integrate 0 dx, I get constant. So please remember this. Okay. Second rule. If I integrate constant dx, what do I get? If I have a constant times x, if I differentiate, I will get a constant. Am I right? So I try to write the constant as k instead of, so this is k. So I will get back k. What is it? So you integrate the constant, what do you get? You get the constant times x plus another constant. So this is the second thing. So third, we come to the rule. That is, so all the constant here, I'm not going to use C. Okay, I can use A. If I have a number times x to the power of n dx, in this condition, x cannot, sorry, not x, n cannot be -1. So my integral will be, so integration is the inverse of differentiation. So now you power +1 instead of minus, times you do divide. Divide by the new power. Then plus C. So this is a very important formula. Do you get me? Condition n cannot be -1. Because if n is -1, -1 plus 1 equal to 0. So this rule cannot apply. If n equal to -1, you look, if I integrate, follow this rule. The new power is 0. So this is undefined. So cannot be used. Are you clear? So rule number 3, are you clear with rule number 3? Okay, good. Let's have a look at examples. How am I going to tackle question like all this? If I give you find the integral for each of the following. Okay, A, integrate 5 dx. Kevin?
Five x.
Will I give you full marks?
Oh, sorry, 5x plus c.
Okay. B, integrate 6x plus 7 dx. So I told you already, if you have a plus, you can split into 2. If you don't want, also can. If you know. Okay. So when I have 6x means 6x to the power of 1. Okay, Krishalini. What is the integral for 6x? What should you do to the power, Krishalini?
+1,
Okay, so 1 plus 1 equal to?
2,
Yeah. Then do I need to divide?
divide by 2,
Okay, I integrate 7.
7x,
Yeah. Then I plus C. So I follow the rules. So now, if I have a situation like that, what should I do? If I have this, what should I do? Andy? Andy Siti Hajar tak ada hari ini. Ah, ada Aiman? Aiman?
Yes, miss.
Okay, Aiman.
Just copy the 2x cube plus 1.
Can meh? There is a square here. Wow.
2 plus 1.
Tak boleh. This formula only for single term. Where am I? This formula only for single term. Where am I? Wait. This formula only for single term. It cannot be of this form. Dia ada plus 1 di sini. So please remember, if you have cases like that, you have no choice to expand. Understand? You cannot. So when you have a square, you expand. So you cannot do any integral until you expand. So I have front square plus 2 times the front times by the back, then the back square dx. Are you clear? You have to expand. So I have integrate 8x to the power of 6 plus 4x cubed plus 1 dx. So now you follow this formula. Remember, n cannot be -1. So this will be a x to the power n plus 1 divided by the new power plus c. So follow the first one. Power 7 divide by 7. Power 4 divide by 4. You integrate 1, you get 1 times x, then plus c. Are you okay? So these are the few techniques that you have to remember if you want to do exercise 4E.1. You
Miss,
have no choice. Yeah.
Isn't it 4x power 6?
Why 4x power 6? May I
Because,
know?
2x power 3 square it, isn't it 4x power 6?
Yeah. I where got square?
Is it? No,
Wait.
no, 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 the front one, the front one.
Yeah, power 6.
Yeah.
2 times, oh, should be 4. Shouldn't be. Sorry. Should be 4, shouldn't be 8. Yeah, you are right. You are right. I'm wrong. This one should be 4. Okay. Are you okay? So one more technique. One more technique is this one. If you see a question like this, if I ask you to integrate okay, so this one you have no choice, you have to split. It's a must. Okay, so this is power -3 plus this one is power -2. Why? 1 minus 3 is -2. So your indices have to be very good now. So Negative 3 plus 1 is negative 2. Divide by the new power. Plus negative 2 plus 1 is negative 1. Divide by the new power. Plus C. So I have negative 1 over 2x squared minus 1 over x plus C. So all your indices, you have to be very, very familiar with it. Like for example, if bottom is a number, you don't have to care. So all the sines, cos, you don't have to do first. Huh? Only do algebra. Yeah. Are you clear? Sin, cos, all is not in your SAT 3. So question involves sin, cos, you don't have to integrate first, okay? So now you have to remember square root of x is x to the power half. X square root of x is x to the power of 3 over 2, that kind of thing. And 1 over x root x is x to the power negative 3 over 2. Are you okay? So far, so good? Okay. Another basic rule. Okay, this is for this. So I'm going to go back to that. Another basic rule that you have to remember. That is for, if I integrate a e to the power of okay, one very important thing. This one must be linear. If it's not linear, you cannot use this formula. The power of e must be linear. So you copy down the whole thing. Then you divide by the coefficient of x. Okay, 1 minute, 1 minute. I finish this, then I stop. You divide by the code, then plus C. So you try to apply this by yourself. Because some of the question in exercise 4E.1, you need to use this. Okay? So I will see you on Wednesday, physical class. Please try all the question in 4E. Then I will teach you 4F. Yeah? Okay, thank you, class.
Thank you, ma'am.
Thank you, miss.
Thank you, miss.
You miss.
Thank you, miss.